still at least draw a slope field. Maybe not understand. I think all of you guys will be fine with slope fields. So let's slope fields give a picture of the possible solutions to differential equations. Now let's write that down. So let's do like a really easy differential equation. So dy over dx. We're going to do the one, we'll draw the slope field 2x minus 1. So if we have to solve this, then we are going to multiply both sides by dx. And then this one's really simple because we just have our dy over here on this side, and we just have 2x minus 1 over here on the other side. So if we integrate both sides here, we're going to get this y equals, and we'll have x squared minus x plus c. So whenever you get that solution, and general solutions is all we have done so far, when you get that solution, what you really have is an infinite number of solutions, right? So all of your solutions can be different based on what that plus c right there is. So if we go to Desmos and just graph this real quick. So y equals x squared minus x. So this would be if c was 0. This is what you would have. But maybe c is 3. Maybe c is negative 2. Maybe c is negative 6. All right. Maybe c is positive 2.5. Oops, not that. So you have an infinite number of solutions, but all of them have the same shape. The only difference in this particular case is that they've been moved up or down. All right. So sometimes we'll be asked to draw what is called a slope field, and the slope field gives us an idea of what the graph will look like. So for example here, let me move this. I'm going to put this over to the side for right now. So what I want you to do is just draw an x and y axis, and it'll probably actually be okay if you just go to like positive 2, negative 2, because these kind of take forever to draw. You make them too big. And then you'll see I have instead of having grid lines, I have little dots at all the places the grid lines would intersect. And that's what it will usually look like if you're doing a slope field. So, this is what we do for a slope field. Slope fields especially can be useful if you have something you can't separate and take the integral of. But what we do is, we've got dy dx equals 2x minus 1. We are going to take every single point and find the derivative at that point, all the ones that are on our graph anyway. So like, I'm going to leave off these 3's right here because they get kind of big, and you can't really if we do the whole grid that we have here, it'll take us forever to do. So we're going to do a little bit smaller of a slope field. So, like, let's just start at the point 0, 0, right? So I'm going to do this. I'm going to make myself a chart. So x, y, and then I'm going to have dy, dx. So if x is 0 and y is 0, then when we plug that into this equation, 2 times 0 minus 1, we get negative 1. This particular slope field, does it matter what the y is? It doesn't matter at all, because when you plug, there's no y to plug in for, right? So that would mean, like, any place, all the y's here, it really doesn't matter. So, like, if I've got, 0, 1, I'm still going to get negative 1. If I get 0, 2, still get negative 1. 0, negative 1, I'll still get negative 1. Right? All the y coordinates don't really matter. So this is what we do for a slope field. We're going to go to the point 0, 0, and we're going to draw us a little tiny line that has a slope of negative 1. All right? And then because all of these have the same, everything on this row really is going to look the same. I'm going to go ahead and put that one in there. We might use 3 because it won't be that much harder. All right. So you just draw a little line that has a slope of negative 1 on 0. Okay. So then let's move up. Let's consider all of our where x is 1. So we could have like 1, 0, 1, 2. They're all going to be the same, right? So what is our slope if x equals 1? Is 1. 2 times 1 minus 1 gives you 1. All right. So right here, we're going to have a slope of 1. Hold on. I've done this terribly backwards, haven't I? Because, are all of my x's 0 right here? I should have went vertical with that. I should, because this is not the point 0, 1. This is the point 0, 1. Sorry. I get mixed up with these badly. So, be really careful. Some people are much better at, sometimes I have to write these out. Some people can just look at it and do these. I cannot, as you can see, because things are falling apart there. So if x is 1 and y is 0 or whatever else, we get 1. So that's going to be right here. So we're going to have a slope of positive 1 for all of these. What about if we plug in 2? We're plugging into the derivative. We get 3, right? 2 times 2 is 4, minus 1, that gives us 3. And so we'll have a slope of 3. Now, it's kind of hard to draw a line with a slope of 3. I usually try to sort of picture, like, if it had a slope of 1, 2, 3 over 1, I'm trying to go, like, through that point. But really what's important is that it's a lot steeper than the ones you just drew in that last line. Okay. So let's do negative 1. So if x equals negative 1, what will I get? Negative 3, right? 2 times negative 1 is negative 2, minus 1 is negative 3. So you'll have, this needs to be steeper than that negative 1. What do we get if we plug in negative 2? Negative 5. So here, these are really steep. Sometimes it's hard to really differentiate a whole lot between negative 3 and negative 5, especially when you're only drawing a tiny line. They put these on the AP exam a lot, and sometimes where you even have to draw them yourself. But what they're looking for is like how good your lines look in comparison to the others. So they're not going to get out some sort of ruler and measure to make sure this slope right here has this tiny line has a slope of -5. It just needs to look a little steeper than this one, and this one needs to be steeper than this one. They need to look correct in comparison. And then if you look, you can kind of see the shape of this graph, right? You can kind of see what these look like. If I take this is a picture of several of the solutions with different C values, and you can see they kind of fit the way you see those tangent lines going. Because these are all your little tangent lines at each point. So the slope field gives you a picture of what that graph looks like. Especially if we did a bigger slope field, we would really see all of these start to look like sort of parabola curves whenever you put all those little tangent lines in. Okay. Questions? All right. Let's do another one. Now this next one, our derivative is x minus y. And they did this a few years back on the AP exam, and it really threw kids off. Can we take the integral of that? Can we separate it and take the integral? We cannot, because we've got x minus y, so we're not going to be able to separate those. So as far as what we know how to do, there's no way for us to actually, integrate that. But if we draw a slope field, it'll at least give us a picture of what the solutions look like. So this one is harder to do because this one has an x and a y. So let's just start. Let's start at the corner over here, -2, 2. So we won't do the 3's on this one either, just so it'll fit. So if I have x minus y, and I'm looking at the point -2, 2, what will I get for the derivative there? -4, right? -2 minus 2. So make sure you're plugging in here. You got -2 and it's -2. So we'll get -4 for that. So at this point, -2, 2, I want to draw a line that has a slope of -4, which is a pretty steep negative slope line. And let's go, I guess. See, on this one, like on the last one, we knew each band that was vertical was going to be the same, which made it a lot easier to do that slope field. In this case, that's not going to work. So I'm just going to go across, I guess, let's go down, -2, 1. All right, so -2, 1, what will we get there? -3. So we'll have a slope a little less steep than the one before. Yeah, so then we've got -2, 0. What do we get for that? -2. So a little less steep than the one before it. What about -2, -1? This time we'll have -2 minus -1, which really becomes like a plus. So -1. And so that has a slope like this. What about -2, -2? That one's 0. So 0, what does that look like? horizontal line. Okay, can you tell me where all the horizontal lines are going to be? Like -2 is going to have a horizontal line. Where else? 2 will have a horizontal line. Where else? 1 1. -1 -1. And 0 0. Alright, so sometimes you can sort of see some patterns that'll help you get like parts of it done without having to write every single one of these out, but if you're unsure, write every single one. Usually on the AP exam, if they ask you to draw one, they only give you like 8 or 9 points you have to plug in, which doesn't give you a very good picture of what the results look like, but it does allow you to see it a little better. So let's do -1 2. -1 2. What do we get? -3. So that's a slope of -3 here. -1 1. It's going to be -2. -1 0. -1. Then there's our 0. What about whenever we've got -1 -2? -1 minus -2.
Oh.
+1. And if you're really good at this, you can start to notice patterns like whatever this number is, you're just increasing by 1 each time, and that seems to be happening everywhere, but I have a hard time with it sometimes, so I usually have to make a chart or mess it up one. So like if I have 0 2, that's going to be -2. If I have 0 1, it's going to be -1. If I have 0 -1, it gives me +1. And then 0 -2 is going to give me +2. Now I am starting to see something happen here. Look at your diagonals. All of these are the same, right? -1 -1 -1. What do you think that one's going to be? It's going to be -1. Right? Here I had +1 +1. What do you think these two right here are going to be? They're going to be +1 also. So if you start to notice some patterns, like in this case, all your diagonals have the same slope. I still get a little mixed up though. So 1 and -1. So that would give us 2. So we have a slope of 2. And that diagonal is all going to have a slope of 2. We had 1 -2. We're going to get 3. So a slope of 3. I'll put those in that diagonal. And 2 -2. That's going to give us a slope of 4. And we'll stop there. So you can kind of see you've got this curve. What does this sort of look like here? It sort of looks like a line right there. That probably is an asymptote right there. So what you've probably got is like some sort of curve. You might have, this is probably something with like a slant asymptote. So you might have something, your solutions might look something like this, and this maybe, something of that nature. That's probably not quite right. I think you've got to have sort of a vertical asymptote with that too. But we can start to see. whenever you're drawing slope fields, I think it's a little hard to see what it looks like unless you make a really big slope field. We'll also have some problems where we're given a slope field and we have to match it to what the derivative was. Yeah, you need to. But on the AP exam, I guess no. But you can use the corner of the edge of your calculator if you need to, or your paper. So let me give you guys. Let's see, I think this is all I had. Yes.